In this video we're going to look at the properties of all the different types of quadrilaterals. First couple you will know, of course, rectangle and square. So just a reminder about some of these symbols. So where you see these arrows here, that indicates that those two sides are parallel to one another. You can see there's single arrows as opposed to these two here. You've got double arrows indicating that those two sides are parallel to one another. The next symbols that you need to know about are these little lines or sticks. Where you see those symbols, that indicates that those two sides are of equal length. And if we look at these two double lines here, that indicates that those two lines are of the same length. Now what else we've got here are two red lines, so these ones here, and those lines are called diagonals. And with a rectangle, those two diagonals bisect each other. So bisect means divide in half. So all these lengths are equal. So once we realize this with diagonals, we can see that we've got some isosceles triangles here, which from our work with angles, we can work out that these two angles here are base angles of an isosceles triangle, which means that they are equal. So this angle here, this triangle here, if we call A, is exactly the same as this triangle here. They are congruent. They are the same. We've also got another pair of isosceles triangles here. So these two are equivalent, and we can work out these angles here. Now another thing that we should note is that we can work out vertically opposite angles where the diagonals bisect, so these two angles here are equal, and then these two angles here, so this one and this one here are equal. So we can use information about lengths of diagonals and sides, the parallel nature of the sides, as well as identifying isosceles triangles within a rectangle in order to solve problems. Let's move on to a square. If we look at the diagonals here, they actually cross at right angles. So these angles here are all right angles, and the diagonals also bisect one another. So all these lengths here are exactly the same length. Okay, I think we'll move on now to looking at a parallelogram and kite. And then we've also got isosceles trapezium and a rhombus. Okay, let's, because we had a look at a square, let's go on to a rhombus. So a rhombus has all equal sides in length. So all sides are equal in length, and we've got two pairs of parallel sides. Now if we have a look at the diagonals here, the diagonals in a rhombus also, the diagonals also bisect, they don't bisect one another, but they intersect at right angles. So these angles here are all right angles. Another thing about a rhombus is that opposite angles are equal, so those two angles are equal, and that angle is the same as this angle. Okay, and one other point about a rhombus is that the diagonals bisect the interior angles. So if you look at this diagonal here, this angle, so if I put an asterisk here, that angle is exactly the same as that angle there. So this diagonal, that diagonal there, bisects the interior angle. Likewise, do these, that diagonal also bisects this angle here, so cuts the angle in half. Okay, let's have a look at a parallelogram. So with a parallelogram, the diagonals do not intersect at right angles, but we do have equally opposite, vertically opposite angles that are equal. So wherever two lines cross one another, so those two angles are equal, and these two angles here, this one and this one, are equal. The diagonals do not bisect the interior angles, but we can say that opposite angles are equal. So opposite interior angles are equal. Okay, if we move on to looking at a kite, so a kite has two pairs of sides that are the same length. So these two sides here are the same length, and then these two sides here are of the same length. With the diagonals do cross at right angles, and we also have a couple of isosceles triangles within a kite. So if you look at this triangle here, that is an isosceles triangle, and this triangle here is also an isosceles triangle. So we can use our rule about base angles of an isosceles triangle to solve problems to do with kites. The last polygon we're looking at is an isosceles trapezium. An isosceles trapezium gives us two sides that are of the same length. So we've got these two sides here that are parallel to one another. The slanting sides here are of equal length, which means that this angle plus this angle here add up to 180. So one last thing to do with the diagonals of a parallelogram and a rhombus, the diagonals bisect each other. So what that means is, if we look at the parallelogram, we look at this point here where they intersect one another. This distance, so from here, from the center or from the intersection to here, is equal in length with this length here. So those two parts of the diagonal are of equal length, and likewise with the next diagonal. So this length here is the same length as this length here. So exactly the same thing with a rhombus. The diagonals bisect each other. So we can say that this length is the same as that length. So from the intersection to that interior angle. And then these two lengths are also of equal length. If we look at a kite, there's one of the diagonals bisects the other diagonal. So if we look at this, the longer diagonal, that diagonal actually bisects the shorter one, so cuts it in half. So this length is the same as this length here.